Here is, I think, a good figure of a mature thunderstorm cell in its mature stage. Now, this is a classic example, but not all thunderstorms will look like this. You see, we talked about an updraft. We see an updraft, and we see the downdraft, right? And associated with the downdraft, we see this precipitation underneath there. A few other features then we talked about the anvil, and I mentioned that the anvil will be longer, pointing in the direction that the storm is moving. We also see, remember, it's got this, what creates the anvil is it bumps up against the tropopause. So I'm going to put T for troposphere, S for stratosphere, and what separates them is the tropopause. Then another feature here is called overshooting tops. And overshooting tops is kind of this, they're usually nice and crisp, basically, and it's overshooting the anvil. Basically, that is crazy degree of instability. Okay, basically you have the updraft that has poked into the stratosphere. Is that not cool or what? Let's see, a few more things. So the downdraft is where you're going to get your precipitation. Okay, now if you've ever been sitting on your porch, I'm just going to draw a person. You're sitting on your porch, kind of watching the storm roll in. And sometimes in advance of the precipitation, you get this, all of a sudden the wind picks up. And so what that actually is what we call the gust front. So that downdraft, okay, that's created because of precipitation falling from literally moving liquid, liquid water or solid or ice crystals, creating a wind that goes down. It splashes on the ground and it goes all directions. And one of the directions it goes is actually in advance of where it's headed, and it creates this gust front. So more to come, right, if you feel that gust front. Now, I want to mention something, and it's not marked here, but see this associated with the updraft, okay, this is called inflow. Okay, and it's probably not as important as the gust front this semester anyway, but I think it's interesting that you actually have this air going in associated with the inflow, and you have, of course, the wind associated with the gust front coming out. Okay, so switching gears a little bit, now that was kind of an ordinary thunderstorm cell. Now I want to talk about something called a super cell, or a super thunderstorm cell. Okay, now supercells, you've probably heard about meteorologists talk about them, and they go through the same three stages: cumulus, mature, and dissipating, as the ordinary thunderstorm cell, but they last longer. These individual cells can last 2 to 4 hours, and they're larger. These supercells, these super thunderstorm cells, they're larger, and they most oftentimes bring what we call severe weather. And by definition, what severe weather is, and I looked it up, see if I can remember it, they being the National Weather Service, will issue a severe thunderstorm warning if the winds are in excess of 58 miles per hour, that's 50 knots, and this is kind of a newer criteria, your hail, the storm needs to have produced hail that is at least 1 inch. I think it used to be 3/4 of an inch. At that point, they will call it severe. They will say it's a severe thunderstorm and give a warning. Okay, so these supercells, they're large, they last long. Okay, and when I say that, I guess the third criteria, the wind speed, the hail, a certain size, and been known to produce tornadoes. And I have a slide or two on tornadoes coming up. But tornadoes aren't entirely well understood, but it's one of the things that I think we know this, scientists know that, is tornadoes drop down from what's called a mesocyclone. Now, you can kind of see, hopefully, the features of, I'll put TS for thunderstorm. So you can see that this is a thunderstorm in its mature stage. If you look a little bit, you'll see kind of the same convention. The red is actually the updraft, and you can kind of see the blue here is the downdraft. Now this is a supercell. So this is a severe supercell thunderstorm. And what's happened is that we have this moving, let's see, the updraft is actually rotating around within the cloud. I kind of go blah, 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 kind of rotating around, kind of like a core going up. And the updraft wraps around the downdraft, and that actually is what can, well, that brings some interesting things, but it's that mesocyclone that possibly can spawn a tornado. You can kind of see this tornado down here. Okay, let's see, what else do I want to say? I don't know where let's see, how do I say this? I think I missed it on the previous slide, but can you see where, I'll take my purple, can you see where the kind of core of this storm is tilted? Okay, it's kind of leaning there to the right. Okay, tilted thunderstorm cells in general are notorious for showing that we have a fair bit of what we call wind shear up here. Okay, the wind is going very fast at upper elevations to kind of create the tiltedness. Tilted thunderstorm cells actually then can last longer. Their updrafts and downdrafts don't necessarily interfere with each other. Tilted thunderstorm cells like this can have mesocyclones form within them. So tilted thunderstorm cells are kind of scary. I guess one more feature to talk about that I kind of already mentioned, you see the anvil there. Okay. All right. So I also want to mention this idea that thunderstorm cells sometimes come in a thunderstorm system, in a system of thunderstorm cells. And each cell actually still goes through the cumulus, mature, and dissipating stage, but at different times. So here we have the two types. The first of two types is called a squall line of thunderstorm cells, and I bet you've seen this before. Okay, so basically this is a radar image, and you can kind of see the line of thunderstorms, okay, extending across several states. Oh, it looks like a smiley face. Sorry, I couldn't resist. So we talked about weather fronts in here, and cold fronts are great for having that abrupt lifting of the warm air, potentially moist air that's in front of it. And with that lifting comes the formation of cumulus and maybe even cumulonimbus clouds. And so basically we have along a front line, and it could also be what we call a dry line, but a cold front or a dry line, we have this lifting. So we have a whole bunch of thunderstorms that kind of live their lives along the front edge. The other type of weather system where we have multiple thunderstorm cells is actually called a mesoscale convective complex. And mesoscale convective complex, abbreviated MCC. And I bet you've experienced these before. These around here, these sometimes can form in the evenings, okay, kind of late night. And it's just a series of thunderstorms that are more blobby, more a blob of thunderstorms. And so I kind of have highlighted here. I don't know if you can make out the states, but this is about the size of a large state. So that red hot blob there actually is multiple thunderstorms that are living their lives, going through those 3 cycles. And very, very intense mesoscale convective complex, the blobby multiple thunderstorm system.